Okay, in this video, we're going to talk about this little vintage amp. This is a 1952, I believe, um, Magnatone student model, and the model number is M-199-3-J. If you are familiar with my other videos, I've had a similar small Magnatone model from the early 50s, which was a Ray Meany model. We'll go through this one and see how similar this one is. The Ray Meany was pretty similar. I think it had the same tube complement, a 6SJ7 in the preamp, a 6V6, and this is the old style 6V6, and it also had a 5Y3 rectifier. This one has a Triad Transformer. These were made in California and used in some of the early Tweed Fenders also. So that's just that transformer alone is probably worth what I've got in the amp. But 8-inch speaker, and that is the original speaker, I'm pretty sure, and it's date coded 1952. The 395, I'm not sure who the manufacturer is. The 2 is 1952, 29th week. I have not looked. This has got to be the original can cap. Haven't really opened it up yet, but I assume I'm probably going to see something that's fairly original. Still has the original cord on it, but it has been spliced in with another cord. So this is all going to be replaced with a 3-prong. And we'll open it up and see what else it needs. But yeah, cool amp, and it should be pretty fun. Well, here's the inside of this little amp, and I'm going to go out on a limb and say I think this might actually all be original. It looks to me like nothing has really been disturbed. I see a couple of bumblebee caps. They're not. These are not coupling caps. One of them over here, this one is in a, this is the death cap. This is one of the electrolytics. We have 3 more electrolytics here in the can. Coupling cap is hidden away back here, and it's, let's see, yeah, it's going over here to the volume, but it looks to me like everything is pretty much original, and there's not, and you know, as I kind of suspected, there's not much to this thing. As I usually try to do with these old things, I am gonna bring it up slowly on the Variac. I'm pretty sure I'm gonna have to replace all these caps, at least the electrolytic ones. Remove the death cap, replace the 3-prong cord. But before I do any of that, I'm just gonna plug it in, hook it up to the Variac over there, and see if we can't get anything good to come out of it. You never know; it might just fire right up. So let's do that, and then we'll see what we actually need to do to this. Okay, we've got it plugged into the Variac now, and got it dialed up to a few volts, around 25 volts or so on the input maybe. And I'm just looking at the plate voltage on the 6V6 right now. Plate voltage on the 6V6 is still climbing, but it's up to about getting close to 42 volts. And what I'm probably going to do, I'm just going to let it sit here until it climbs and then stabilizes. Let it cook on that sort of voltage that it stabilizes at for a little while, and then dial up the dial just a little bit more on the Variac, and let it do the same thing again, and then dial it up a little more and do the same thing again, and just see if I can't get these caps to reform. And if they do, heck, I might just leave them. I mean, it's a cool old amp, and if it works as is, then I may just remove the death cap, put a 3-pronger in it, and and let it roll as it is. And you know, I'm probably going to jam on it for a little while anyway, just to test everything out. So we'll see how it goes, and we'll keep doing this and see if we can't salvage some electrolytics. Okay, we're up to about 60 volts now and still climbing. I'm assuming it's probably because also the rectifier tube is still kind of warming up and doing its thing. But while that's happening, I'm going to refer to the RCA receiving tube manual and find the 6SJ7, and we will see it as a sharp cutoff pentode. It tells us here that the pinout is pinout number 8N. That's that second line over. 8N is the pinout. If you look at the top, you'll see terminal diagram. So yeah, for the 6SJ7, that is an 8N. So if we flip back a few pages and find the terminal diagram charts, we look for 8N, and that's going to tell us which pin is which on this tube. I don't memorize all this stuff. I don't know anybody who really would memorize every single tube. There's a lot of very common ones, and some of them are easy to remember, but something like a 6SL7 is not going to be that easy. So, but it says here, okay, pin 1 goes to the shell. That's what S stands for. Goes to the shell. Pin 2 is a heater. Grid 3, grid 1. So that'll be our input signal to grid 1. Cathode is pin 5. Then we have grid 2, and then another heater, and then our plate is on pin 8. So the two main ones we want to look at are pin 5 is the cathode, and pin 8. So that tells us a little more about that tube at least, and it looks like we're still climbing on this voltage up to about 64.5 volts. So we're going to let this continue to climb, and we'll come back to it. Okay, well, we've brought this thing up to operating voltages. We're around 290 or so volts. It's kind of skipping around a little bit, and we are getting sound. I've got a guitar plugged into it. Doesn't sound very healthy though, and there's a lot of crackling and noise, and just, I mean, you could tell the electrolytics are just shot. So we're gonna power it down and go on the assumption we're gonna have to change all the electrolytics in it, and we'll go ahead and change the power cable, test the other components, and then try it again. Okay, back inside this Magnatone amp, and someone had definitely been in this thing before. If you rewind backwards a little bit, you will see this capacitor was right down in here, and it was coming off of pin 8 of the rectifier tube, and pin 8 of the rectifier tube corresponds to this position, and essentially it was coming right off of here, but it's a 4 microfarad. That's the cap that we have here. And what's more, if we follow everything, you can see there it's 4 microfarads. If we follow everything out, and this is definitely not original, if we trace everything out, there was actually this is a 1K resistor that was going from the same point over and being tied here. So it was going through a 4 microfarad and then through this 1K, and then it was coming to this little tie point, and this pin is just being used to solder things together. Then it was coming over through this red wire over to this 20 microfarad cap in the old can. So yeah, that's definitely not correct. This is not the schematic for this for this particular amp. This is the 197-3-M that I have actually shown in a previous video, and I will put a link to that video up here in one of these corners that you can click on and go to that. But apparently the 197 was close to this one anyway. If you look up the 199-3-J or whatever it is we have here, what is this? The M-199-3-J. It will say it's pretty close to this schematic, and even this one is not even close to that. This has 10s, so I think the one that I have is this one here makes even more sense than this other schematic that I found online, and I drew this schematic out for this model that I had already had. And I think what I'm going to do is redesign the power section after this model, because someone, like I said, had clearly been in here before. It had been monkeyed with before. This is not original for sure. I don't think they would have stuck 4 microfarad cap in there, and I don't think this is of the right era anyway. I think this is a slightly later cap, so that's not correct. We do have our 3-prong cord already wired in, but we need to come in here. I'm probably going to get rid of this 1K, and maybe I may not replace it with another resistor. I may just let that voltage go on downstream. But at any rate, you can see here on this one that the 1K actually came before the first cap, so all it was doing was dropping voltage before it hit this cap. Not sure why it would have been doing that, except maybe they were afraid the voltage was too close to the rating of the cap that they were using in the can. I don't know, but at any rate, this is kind of unorthodox to have a 1K dropping resistor before the first capacitor node here. So I'm just going to I'm probably going to omit this dropping resistor, come straight to like a 20 microfarad cap, because the 20s are what this can is actually rated at. Both of the capacitors in this are 20s. There are actually 3, and one of them is a 20 microfarad at 25 volts, so that one is going to be a bypass cap of some kind, and I think it's this back one back here. So we're going to do something else with that one probably also, but we're going to move all of this stuff over to just coming off of the points where they're running from, and we're just going to omit that. We're obviously going to omit the 4 microfarad cap that was over here that had been added, and we're probably going to omit this resistor as well, and then we'll come back and see where that's gotten us. Okay, I'm here with this little Magnatone amplifier, and just wanted to demonstrate kind of what's going on. I had a really bad hum out of this thing that it actually is controllable with the volume, and I'll show you here. This is with the volume all the way up, and you can hear the amount of hum that's coming out of the speaker right there is just wholly unacceptable. I can actually put my hands in this case on the power transformer, and it actually, you can sort of feel the frequency of that hum kind of vibrating this chassis, and it's not, that vibration is not coming from the speaker, that's actually the chassis itself kind of vibrating. But again, I can turn it all the way down. In this case, I mean, you have to kind of excuse the bad soldering. This is just temporary stuff here. And let me get a pointer so we can look at some things. Here are the leads to the power cable. I've reversed these for this part of the demonstration here, and it's making no difference whether the white one or the black one is in this position, or the black one or the white one is in this position. I have the ground wire for the 3rd prong grounded here. The center tap for the 6-volt filaments, here's the other green wires twisted back here. and the third center tap, which I mean, this is the way it was wired when I got it. This wire was, I presume this is the center tap, but there's nothing really distinguishing this wire from these other two green wires. So I don't know. Maybe I'll pull these other wires and measure them. But I mean, this is definitely a factory job. These wires were twisted together, and going over here for the 6-volt filaments. This is the third wire, which I presume is the center tap, and it was grounded at this point here. Here are my new caps, my new power caps, and I've actually, at the behest of someone online, at their suggestion, I've actually grounded it. You can see right now it's being grounded with this gator clip way over here on the other side of the chassis, where the old caps were grounded. Same point, and that's not doing any different. At someone else's suggestion, also, I switched these leads, which I didn't think that was going to affect anything, since this is a 60 cycle hum, from what I can tell. I mean, that sounds to me like 60 cycle. So I didn't think that was going to do anything about it, and it hasn't. I've also, I mean, to try to rectify this situation, I've done many things, actually. I've bypassed this switch, and I've tied these leads together to eliminate this as a variable, because according to one tech's notes on a schematic from one of these Magnatone amps, in fact, the only schematic that I found online before I drew the Ray Meany model schematic, had some tech notes about, this could induce hum and being this close to the volume pot, but that didn't change anything at all. So that's not it. I'm actually kind of down to the point where I'm thinking that this Triad Transformer probably is bad, has some bad windings. Someone has suggested that I soak this transformer in some shellac for a few days and let the windings kind of soak up all this shellac, and maybe that would kind of help out and prevent this from happening. I'm not so sure about that either. I mean, it's a good suggestion. I may take that on board and may try it. I'm to the point now where I think the issue must be with the transformer. I mean, honestly, I've tried just about everything I know to try, and it's nothing I seem to do has helped. You can pull out the preamp tube, the 6SJ7. You can pull that tube out of the amplifier, and the hum remains. However, you can pull out the 6V6 tube, and the hum will stop. So that tells me that if it's not the 6-volt filaments, it is from the 6V6 downstream toward the output, and not something input related. Although it is curious that the volume control does affect things, but the volume control is actually right before the 6V6. So something is not right. Something ground related, perhaps, or something with the transformer. Some people have suggested that I have some out of balance 6-volt winding, and that a hum pot may be the ticket. I think the next thing I'm going to do, because I would have to take the transformer out anyway to troubleshoot this issue, but the next thing I'm going to do, I think, is decouple the twisted wires, the 6-volt wires, measure those, and just for DC resistance, and see if they're even close from there to the center tap. So I'll measure, one side of the center tap and the other side of the center tap maybe, and see if those, at least the DC resistance on those, is somewhat close. Maybe that'll tell me something. I don't know. And then the next thing I might do is actually put a little bit of voltage on the primary, and then measure with those disconnected, and then measure and see what kind of voltages I'm getting through there. But that's kind of where I stand at the moment. Massive hum, and nothing I seem to nothing I seem to try here is fixing the hum. So I'm to the point where I'm kind of dreading this, but I feel like maybe the next step is to replace that beautiful Triad Transformer, and I really don't want to have to do that. But that's where we stand, and hopefully. Hopefully it doesn't come to that, but I'll report back again and see where we are. Okay, I'm back with this thing again now, and I've reversed the wires the way they should be. The black wire, which is hot, I'm going through the switch first so it doesn't go through anything else whenever you switch the amp off. But so I've changed those back. But right now, the real test, I've actually removed these wires. These are the 6-volt leads that are going to the 6SJ 7 preamp tube. I've removed those leads completely, so the only thing with 6-volt power now is this tube. So it is not these leads, it is not that tube. That tube's actually doing nothing essentially. There's no fire on it at all. So this is the only tube that's 6 volts with fire on it. And we still have the massive hum. I don't even have the Variac set all the way up. It's set to, I don't know, 80 volts maybe or something. And we're already getting this massive hum out of the speaker. And again, kind of at my wit's end on this. I think the next thing I'm going to do here before I just decide to remove the transformer altogether, I think, is I'm going to remove the 6-volt leads to this tube and do some measurements, and I don't know, man. From there, I guess we'll be on. If I can't find an issue in that, then I guess we'll be on to just replacing the power transformer, unfortunately. So, but yeah, that's where I am at the moment. One other thing before I just leave that hanging, for that last portion of the video, I'd actually forgotten to connect this gator clip to the cathode of the 6V6. However, that really doesn't seem to matter a single lick. I can actually have that connected, and then I can come over here to the center, what I believe, again, to be the center tap, which was the center tap from factory. I can disconnect this even with the thing on and humming. I can clip this lead or unclip it, and it makes absolutely no difference whatsoever in the hum. And actually, I suppose for the purpose of the video, I should demonstrate that, but just in the interest of brevity here, because this has gone on for way longer than I'd hoped, I'm not going to actually film that, but I could turn this thing on and show you where it hums, and then disconnect this once again, and it makes no difference whether this center tap is connected to ground, not connected, or connected to the cathode of the 6V6. It makes absolutely no difference in the hum whatsoever, which I suppose is a little bit unusual, but maybe that's why they didn't even bother connecting the center tap in the Dickerson 1946 amplifier. That schematic again shows that the center tap was connected to nothing, and I guess their engineers just realized that it didn't do any good either way anyway, so they just didn't bother. But kind of where I am right now, once again, I think the next step is to remove those 6-volt leads, and we'll do some measurements. Okay, I've removed the 6-volt twisted filament leads and have them here out for testing. I'm hooking my ohm meter to one side to the positive there, and then the other lead is going to the center tap over here, which has been disconnected from the chassis once again. For this measurement, I'm getting about 1.1 or 1.2 ohms. We'll take this off, clip off, and move it to the other lead. So we'll clip it on there and then measure that. Let's see, right now it's got open lead. I'm not sure what's going on there. I did get a measurement a bit ago, I thought, but for some reason now I'm getting an open lead. Well, that's strange in and of itself, because I promise you I was getting a measurement. Okay, there we go. I actually wiggled the wire over here. I think this one was bit loose. Or it could be that wiggle in this wire is causing some kind of short or something to happen in there. So I don't know for sure, but let's see. Let's try clipping it on again. Okay, it is doing something. I'm going to wiggle this wire again. Well, there we go. About 1 ohm right there. 0.8 ohms. So at any rate, okay, now we have, again, we have it clipped there to that one side. A little bit less than an ohm. Let's try the other one more time. Clip it on over here just to confirm. And yeah, we're right around the exact same, you know, 0.9 ohms. So it's the exact same over here as it is over here, which is a bit curious. Usually you would expect them to be somewhat off, but more or less it's the exact same. Now, a minute or two ago I was getting a bit different reading, and I think it might have had something to do with where I had these leads placed. If you move these around, it will change it somewhat. But, you know, right around 1 ohm is what we're getting no matter what here. Now, if reason tells me I should be able to disconnect from the center tap and connect over here to this lead, and I should get, you know, what, something like 2 ohms through the entirety of the winding. Since this half to the center tap was 1 ohm and this half to the center tap was 1 ohm, I should get about 2 ohms. But if I come over here, you can see I've got an open lead. So whatever's going on here is pretty serious, because I'm getting nothing from end to end. So somewhere along the path from end to end, I get nothing. However, on both sides to the center tap, I'm getting something, which is, I mean, it's kind of mind-boggling to me. Maybe somebody can explain why that might be, but it makes absolutely no sense to me whatsoever. And I've actually tried to measure this now several times and wiggle wires and everything else, and I still get nothing. So go figure, I get nothing through the whole winding. I get 1 ohm from half and 1 ohm from the other half. So something clearly is not right, and the 6-volt winding is malfunctioning, and that's what's causing the hum. So I think unfortunately we're going to have to ditch this Triad Transformer and go with a new one, or see if we can't find a replacement Triad, which I dread to even think how much it would cost. So let's see what our options are, and we'll come back to this thing. Okay, here's this Triad Transformer. I've gone ahead and pulled it out of the amp and got it out on the bench here, and you can see actually it has the same number on the inside as it does on the outside bell, 6308. That's the model number for the transformer. But yeah, I'm getting the same thing. I've actually pulled all these wires apart, the pairs at least, and spread them out and jiggle them around a bit while taking readings. And yeah, I don't think it's anything like a short or something simple. I might be able to rewire here. I think there's a problem internally. There's definitely some corrosion on the inside of the bells. And actually I can rub my finger across this and you can visibly see the corrosion on my finger. So there's a lot of oxidation there, which may be playing a part, you know, in what's going on. So internally, inside this power transformer, I think things have gone awry, and at least for the 6-volt winding, and it's for that reason going to be toast. I might be able to actually, if I can find a transformer of the same size, I might actually be able to reuse these bells. So if nothing else, it'll, you know, look the part on the outside of the amp. I mean, not trying to pull the wool over anyone's eyes or anything like that. You know, I'll let them know that it's not the original transformer, but at least it'll still look nice. It'll still have the little Triad code and logo and everything there, so that, which I think is kind of cool. So yeah, I might try to find something where I can reuse these bells and make that work. But at any rate, we're definitely going to need a new transformer. So that's a big bummer, but that's where we stand. I do actually have another transformer on hand. This is a lay-down type transformer. In other words, it's the kind that sits on the amp in this fashion, and the wires go down inside in that fashion. But I do have this on hand. The laminates are actually a little bit bigger. This is sold through Antique Electronics Supply, CE Distribution, and I already had this on hand for I don't even know what. I think I was going to build another single-ended amplifier at one point. So I've got this one. So what I might try to do, and I haven't tried this before, but I might take these bell ends off and put the old bell ends on that one, just to get, again, so it kind of looks the part. And plus, this is the stand-up type bell end, so I can convert this to a stand-up transformer by using the other bells. That's going to prevent me at least from having to order another transformer. And already having this one on hand is nice. Again, the laminates are thicker on the newer transformer, so actually it should be a little better transformer in theory. You can see the thickness of the laminates there. It's a little bit thicker, but that's not really going to matter. That's going to push the screw holes apart just a little further. But fortunately, in the amplifier, the screw holes are oblong, so you can you've got some play room there on each of the screw holes. So I think it's going to work out actually. I will go ahead and put the bell ends on this transformer and install it, and I think that's probably going to fix the issue. And heck, it may even be, in all honesty, it may even be a technically better transformer in the end. So at any rate, it's not going to be 100% original, but I don't know a whole lot of people who seek out these early Magnatones anyway just to collect those. And even when you do, you usually have to do work on them regardless, because they're from the late 40s, early 50s. So it is what it is. It's going to be one with a replaced transformer, but at the end of the day, it's going to be one hopefully that works as it should. So you always have these kinds of trade-offs, and I was hoping to avoid it, but that's where we've ended up. So I may take this suggestion actually of an online friend whose experience and opinions I actually quite value, and he said, I might be able to soak this thing in some shellac, and soak this side for a few days, and then flip it over and soak the other side for a few days, or even maybe drop it in entirely into some shellac and let it just soak it all up, and maybe that would help. But I don't see how that's going to fix the fact that I have open leads on the 6-volt winding. So on second thought, I may not even do that. But at any rate, there it is, and there's what we're faced with. And let's see if we can get these bell ends, the old bell ends, on this new transformer. Okay, we got these old transformer bells off the old transformer, and we've got the new ones on. And essentially, again, this has converted it from a lay-down style transformer to a stand-up style transformer that we can actually mount in this chassis without cutting any holes. So I think we're going to go ahead and install this thing, and it's certainly going to look the part. It won't be exactly the same because obviously, again, it's a little thicker, and it's got this band of brass around it, but yeah, let's get it installed and check it out. All right, here we are with the new transformer installed in the bells of the old transformer, and looks pretty good. Looks the part, and we're pretty much ready to flip this thing over. Fire it up. It's all wired up, and we'll bring it up slowly on the Variac and see if she works without hum. Fingers crossed. Hopefully that'll be the case. All right, we have everything hooked up. Here's what she looks like on the inside. It's all wired in. We have our probes. We're going to measure the voltages as we bring them up slowly. Right now and this is at the first node, by the way. Here, I'll put a light on this so we can see it. This is at the first node. I've just started the process of bringing it up slowly here on the Variac. We're about it says about 26 or so volts on the input. And we'll turn it up slowly here. we don't want to go too fast with it. Just want to make sure haven't miswired something, or I mean, because you never know. Everybody makes mistakes, and it's the safest bet to bring it up on the variac. So over the course of the next few minutes here, we're going to bring it up on the variac, and then we'll see whether or not we have that hum back or, again. So let's check it out.